Okay, glad that we are all back here together. So the point of this last session is to nucleate a conversation, get the conversation going at least, on an opportunity that we think would leverage our interests, our strengths. It's just one example of what we might go on to do. I think the next couple of hours after this session will give us time to wander around and find out in more detail what the possibilities are. So I'm going to invite Shane, Professor Shane Seibert, Director of CalIT2 at Riverside, to outline a particular program that he is poised to lead. So, and then we'll fill in the additional aspects of what we are hoping to accomplish.
Pull the mics closer, please. Wait, we're having trouble hearing you all. If you could pull them a little bit closer.
How's that? All right, great. UC Riverside has been kind of working on something that's kind of unique for CalIT2. And what it is, you know, in our area, we're in the Inland Empire of California. I don't know if you're all familiar with that geographically, but it's in kind of the middle of California with the really hot desert and heat, 100-degree days and so on. And also in that area, Riverside County comes in, and then there's Imperial County, and then San Diego County. And right between Riverside County and Imperial County, there's this man-made sea that they call the Salton Sea. And it was created by a disaster about 100 years ago, where they had some flooding of the Colorado River, and it just collected in the desert in this ancient sea basin. And the water is extremely salty, and it's got all these brines and stuff in it. And there's a lot of geothermal activity, like volcanic activity and stuff around the sea. And, you know, for the longest time, you know, like in like the 1950s or so, this was a cool place to go. People used to go there and ride boats around on the sea and, you know, lay out in the sun and everything. And then over time, you know, more chemicals and stuff from the agriculture around started to get dumped into the water and pollute the water. The salinity of the sea kept raising because that water some of the water would evaporate, and they're no longer flooding it. So the salinity is just getting really high. And then all the fish died. And there's like dead fish everywhere and scales. And this was right around when I was a graduate student in around 2000. I first come to California, and I'm like, oh, I'm going to go to the Salton Sea. Yeah, this is a great place. So, like, my sister visited me, and we drove out to the desert, and we go to this place, and we're like, where's the beach? It's like scales and dead fish and stuff. It was like a ghost town. It was not what we thought it would be, right? So, you know, that was my impression of the Salton Sea back then, and it's gotten worse since then. That was 20 years ago. And now, you know, people have just recently discovered with the, you know, electric car boom and everything recently, that there's a lot of lithium out there. And in these brines, there's a lot of valuable lithium minerals and stuff that can be extracted from it. And on top of that, you know, the geothermal activity can be used for power plants. So there's a lot of development now by companies going into the region and developing these geothermal plants that, you know, are extracting lithium out while they're generating power. And it's profitable. So a lot of different companies are looking at that. And there's other regions in the US that have lithium. But one of the unique things that this region has is it has a health problem associated with the evaporating stuff. So like other regions in, like Nevada and so on, don't have to deal with this ancient seabed and so on. And as you go in and you do construction and build things, the air is just getting worse. So the people in the area, they're kind of skeptical of this new industry coming into their environment, because they're like, hey, you're just going to come in here, make it worse, and, you know, take our lithium and leave us worse off than we were in the beginning. So what Riverside has been doing is we just formed a medical school, you know, recently, and we have a lot of clinics out there working in the Salton Sea. We have tons of faculty working out in different things. We have a Salton Sea task force, which is a group of researchers that go out and study these different health problems. And as CalIT2 was founded at Riverside, we're like, why don't we try to do something in the development of batteries and, lithium production? So we put together a team of companies and different researchers from all over, and we submitted a grant to the Economic Development Agency in the Department of Commerce. And the idea was to, study the different problems that are in this region and try to help create jobs that stay in the region. So instead of, taking all their lithium out and leaving, can we build production and manufacturing inside the regions? And recently we, GP and Ramesh all joined us out in the Palm Desert where UCR has a campus, and we invited people from the region to talk about this lithium development. And we heard from the community, some people were very positive about development in the area, but we heard the skepticism about health and, you're gonna make this area worse. And one of the ideas that we had talking in one of our many meetings was, they're really good at monitoring for fire, right? CalIT2 has a real track record that you're going to hear more about, and so I'm not going to give away all the good stuff, but we think that we can use some of these same technologies that's already been developed by CalIT2 for the fire monitoring to do lithium monitoring. Can we look at the environment in this region and help people determine which areas should I avoid on which days? And, is this company that's coming in here and mining lithium over here creating the more pollutants, or, are there things that we can control more and, reduce the pollutants? So with that, I'm going to hand it off to Ramesh.
Sure.
And he's going to talk about the infrastructure.
Shane, thanks very much. Did you want to say a few words about the EPA opportunity that
Yeah,
you're
and
hoping to
I
target?
think foreshadowing, what we're discussing here is we're looking to expand from the EDA, which is the Economic Development Agency, to get funding from the Environmental Protection Agency. And they have opportunities for communities that have been disadvantaged and need help. And just exactly things like this, like, can we get them cleaner water? Can we get them cleaner air? And we discussed a little bit about this in our workshop in kind of Palm Desert, and we really wanted to kind of get some feedback and some good discussions from the community here and hear more about the technology as well.
So one last thing I'm going to nudge Shane to share is a certain congressman who is most remarkable in terms of his affiliation with UC Riverside, his background, and the community he represents. You want to say a few words?
So one of the reasons why we got into the lithium business in the first place is because we were approached by Congressman Ruiz. He is a very active congressman in the area of Imperial Valley. And Congressman Ruiz pretty much came to us and was like, hey, we have enough grants going to San Diego and Orange County. I want stuff going to my district and helping my people. And, we kind of worked with his team in the county of Imperial County, and we put together this plan to kind of develop the area. And Congressman Ruiz came out and gave a nice talk about the region and his kind of vision for how to create jobs and improve the area. And I think the other cool thing about Congressman Ruiz is he's actually joined our medical school. So he is an affiliate of UCR's medical school as well.
He's an MD and an MPH from Harvard.
Yeah.
Graduated from UCLA, and he's on the faculty at UC Riverside. I mean, there's not a lot of people who bring those attributes. So just picking up on what Shane just shared, I do believe that UCs have a huge role to play. The situation in Lithium Valley, Imperial Valley is so complex, and there are so many pressures to both extract the lithium and also enhance that environment, that it's not going to happen by itself. I think you need the kinds of minds that you find at places like the UCs to come up with innovative solutions that create these breakout opportunities. So that's part of the reason why we are excited. I'm excited. I hope we can enlist you in this little journey that expedition that we are hoping to go out on. And part of that led us to think about what resources do we already have to bring to the table. Shane talked about the faculty task force, the Salton task force that UC Riverside has had for a number of years. But I wanted to draw your attention to something that's a part of UCSD's history going back at least 30 years, and that is environmental monitoring. It's an interesting thing because of seismic issues and the way the San Andreas Fault runs. It goes by the Salton Sea. For a long time, Frank Vernon, who couldn't be here. He's out in the field. He was supposed to be here. I'm sitting in for him. They've deployed sensor networks in Imperial Valley, right? And these were pulled together over a high-performance wireless research network called HPREN that goes back many, many years. So we have the ability, UC San Diego broadly, with the scientific community that we have cultivated over the years, have the ability to deploy new kinds of sensors to gather environmental data from that entire region. And so these are physical locations on mountaintops. These are relationships with the folks that control these mountaintops, the antenna towers, the back and forth that needs to take place, so you actually will have access to these locations. And that is something we've had for all these years. But now putting on a different hat, you know, there is this absolutely extraordinary, one-of-a-kind national asset that only California has, strangely enough, which is called CENIC. It's a nonprofit entity that was put together initially by UC and then spun out of UC as a nonprofit, which provides high-speed connectivity for the entire K through 16 segment, right? So at extremely low cost. None of us ever worry about bandwidth when you're working from your machines at work, partly because we have this essentially infinite bandwidth to the rest of the world. The state of California funneling in the American Inflation Reduction Act, the COVID recovery monies, is investing through California $8 billion in extending this scenic network, essentially doubling its footprint. And much of it will target areas that have been underserved for all these years. So there is a whole new ring of fiber going around the Salton Sea in particular. And what's interesting is every 50 kilometers, there's going to be a repeater hut. So from a networking point of view, this is a huge investment the state has made of a kind that I don't think I will live to see happen again, Just extraordinary. The focus right now is in just getting the fiber in the ground and lighting it up. But the longer-term interest is exactly what we are trying to chase after, the economic development, improving the quality of life, improving California for all. We saw that earlier today. So here's this other resource that is emerging, and this is going to happen in the next 18 months. It has to happen in the next 18 months because the monies will evaporate if you don't spend it within that time frame. So really, once-in-a-lifetime opportunity. We have these relationships that allows us to monitor the environment on scale, and we'll learn more about how we can take that capability up a notch. But I have to mention, given the focus on health, that the Imperial Valley healthcare system is UC San Diego is already there at the El Centro Medical Center. Was acquired by UC San Diego. There are 2 other hospital districts in Imperial Valley. There is a plan already afoot to merge them, and UC San Diego Health will be taking care of all 3 medical systems in Imperial Valley. So we'll have UC San Diego medical records will tell you exactly how the community there is impacted by whatever it is that is happening. We have this priceless opportunity to monitor the environment and to understand its effect on human health, right? Like nobody else does. By the way, Irvine, San Diego, and Riverside's medical records it's one integrated thing. We're all on Epic, managed as one system. So in terms of being able to get one's hands on this data set, it will be easy. So that's an important piece of it from the infrastructure point of view. But as researchers, we want to leverage what we have in place and take it up, get a deeper insight into what's happening. And GP has a story there to share with us.
Okay, thank you. So we heard a great story, what is needed in the community for Lithium Valley. And we also heard about the great opportunity because of the infrastructure available to us. And what we try to do here is, can we put in more eyes to see what is happening at location need, the information, and to come up with a better way to manage their needs so that we can balance prosperity and health and quality of life. So at the UCI, we have a faculty member, luckily receive funding support from San Diego through the ALERT California is a Wi-Fi program to introduce a new gadget known as hyperspectral imaging device. And so because he need to give a lecture today, so he would not be able to participate, but ahead of time, he made a video for us to tell you about the technology. I am pretty familiar with the technology. I did some work early on in my career, so I can help to answer some of the questions, not all of them. So is there any way we can show the video right now? Thank you. Yes, it's a Professor Grant Healy. Sorry, I forgot to mention his name.
Good afternoon. I'm Glenn Healy from CalIT2 and the Department of Electrical Engineering and Computer Science at UC Irvine. And I'm happy to be part of this session on addressing the environmental and public health crisis in Lithium Valley. I'm sorry that I'm not able to be there in person, but I believe that Professor G.P. Lee, who's the director of CalIT2 at UCI, is in attendance, and he's familiar with a lot of what we're doing. If you have specific questions for me or would like to be involved in this project in any way, I will put my email on the last slide. Lithium Valley is in Imperial County, California, which is east of San Diego, so you can see on the map. And if you look in the enlarged area here in the circle, you can see the Salton Sea in the area. And then down and to the right, we've got this red area, which is the sea's known geothermal resource area called the KGRA. And this area is estimated to have enough lithium for the production of 375 million batteries for electric vehicles. So the lithium industry has the potential to bring significant economic development to the region. And a few months ago, we had an EDA-associated workshop at UCR Palm Desert that Shane Seibert organized on clean tech strategies for the valley. Now, the Salton Sea, which helps give us all of this lithium, is shrinking, which brings dust contaminated by pesticides, fertilizers, and other toxic chemicals into the air. And the air quality in the region is already among the worst in the nation, with high levels of particulates, PM 2.5, PM 10, as well as gases such as ozone. And the pollution has a lot of negative health impacts. The asthma rate in the region is about 2 or 3 times the national average. And with the possibility of a lot more new industry moving into the area, and the fact that the proposed lithium extraction processes have never been used before at commercial scale, there's an additional, not yet fully understood, potential impact on air quality. And one of the things that we learned at our previous workshop was that the somewhat small number of air quality measurement stations that they have are not sufficient for monitoring the environment. The way that I've gotten involved with this is by working with the Alert California program, which is led by UC San Diego and which grew out of the HP REN program. And Alert California includes a network of more than 1,000 cameras throughout the state, and you can see the locations on the map. And almost all of these cameras are color video cameras, and many of the wildfires in the state have been first detected by people looking at the feeds from these cameras. Now, I've been working with multispectral and hyperspectral imaging for many years, and we've been funded through Neil Driscoll at Alert California, and with the help of Frank Vernon and his team, to deploy multispectral and hyperspectral imagers at Alert California sites. And our first spectral sensor deployment is going to be at Birch Hill on the top of Palomar Mountain. We've been out there a few times and everything's ready to go. And we will be collecting data 24/7 starting in early November. You can think of multispectral and hyperspectral imaging as being a generalization of a color image. Color image, you get 3 spectral bands. You get a red, a green, and a blue. And then multispectral, you get more than 3, usually up to about 20 bands is considered multispectral. And with hyperspectral, you can get more than that, up to hundreds of different spectral bands. So we've got a hyperspectral example on the far right here, where the bands are very close together. And so at every pixel, you can think of getting a full spectrum. The sensors that we're going to put on the top of Palomar Mountain will give us high-resolution spectral images from the shortwave visible all the way out to the long wavelength infrared. And this will be done with a 500 band hyperspectral high-specs camera that covers 0.4 to 2.5 microns, visible through shortwave infrared. And then we're going to have an 8-band multispectral teleops camera over the midwave infrared, and another 8-band multispectral teleops camera over the long-wave infrared. And this is the first time that a set of sensors with this spectral coverage has ever been deployed to continuously collect data. And they'll be sending back 1.4 gigabits per second wireless. And we'll be using these to assess air quality, as I'll describe a little bit, and also for wildfire prevention and mitigation. And the big advantage that this approach has over current approaches is that we get high quality information over a wide spatial area, the full field of view of the sensors, continuously. And as I've mentioned, current air quality measurements are limited to the location of the monitoring stations, and quantities like live fuel moisture for fire risk assessment are also severely limited in time and spatial sampling by the manual processes that are used to collect this data. I'll talk a little bit about how this technology works. From the hyperspectral image data, we can compute the aerosol optical depth, and that is directly related to the PM 2.5. Here's an example of computing PM 2.5 from hyperspectral data and comparing to ground measured PM 2.5. You can see that there is a strong correlation. And again, the advantage is that we can be doing this continuously at high spatial resolution across the field of view of the sensor. And not only can we get the total particulate with something like PM 2.5, but because different kinds of aerosols have different spectra that they give us, and we've got a few examples here of sulfate dust and brown carbon, we can separate out the different aerosol constituents that are causing the degradation in the air quality. Here are some examples of recovering the AOT, or the aerosol optical thickness, which is a measure of concentration of various aerosols from the hyperspectral data. And again, we see that there is a strong correlation. In addition to recovering the amount of the particulates in the atmosphere, we can also detect and quantify the concentration of various gases, because gases emit with very narrow spectral features. So this is something that you could not do with say, an RGB type camera. You need something that is multispectral, tuned to these gases, or hyperspectral. And we see an example here for potassium emissions that we can detect. And this was for a wildfire case, but you see here that we can even detect these emissions through the smoke. The filters have been designed for our spectral sensors to allow us to detect and quantify the concentration of the various gases that are released from wildfires, and we've listed those here, along with the different spectral ranges, visible, near infrared, shortwave infrared, midwave, and longwave, that we can detect these over. If there's other gases that we're interested in for air quality measurements, we can design filters for those as well. And I'll talk a little bit about the things that we're doing for wildfires. Before the fire, we can map the various kinds of fuels that are out in the scene, and then we can map the fuel condition. And of particular interest is the moisture content of vegetation that determines the likelihood of ignition and the likelihood of spread. And what they currently do is similar to what they do with the air quality sensors. I've been out with these guys. They take Orange County and they will represent a very large area with just one small site, and within that one small site, they'll maybe collect 5 grams of leaves that they can put in their pocket, and they'll take those back to a lab, and they'll measure the water content of those 5 grams of leaves, and that'll be representative of, say, 40,000 acres of area. So again, we're not getting a very good sampling of the environment. So what we can do with these spectral sensors is we can determine the moisture content of all of the vegetation in the field of view of the sensor, and we can be doing that continuously. When they go out and collect this data, they usually only go out once a month, and they take those leaves. And one of the benefits of using hyperspectral sensors is that we get so much information at every pixel, this full spectrum, that we can disentangle just about any of the variables that enter in. So here it was of interest to try and recover the moisture of the leaves. And you see here that we can do that very accurately. We can do things like make these vegetation health maps that were made for an area near Irvine at Loma Ridge. And this will give people information about the probabilities of fire spreading in any given direction. When fire starts, we can detect it using the spectral data, even if it occupies a small fraction of a pixel. And we can accurately characterize the boundaries of the fire through smoke and quantify the temperature and emissions of the various fire products into the atmosphere. And this is just an example of using these instruments to look at a fire. We're looking at the exact same area. The left is visible, RGB, from a standard camera, and then the right is looking at the shortwave infrared. And then the 2 lower images are zoomed in, and you can see we get much better information about the fire looking in the shortwave infrared, where we can see through the smoke. And this is looking at the exact same area, same time, with the midwave infrared multispectral. You see the fire is at very high contrast, and we get a lot of additional information about the fire. And this last one is the longwave infrared multispectral. And again, you see that we get the fire with very high contrast. So it's very easy to detect using all 3 of these different instruments. After a fire has occurred, we can assess the severity, we can track recovery, we can map the various fire products. So that's it. We're putting multispectral and hyperspectral image sensors on the top of mountains or wherever we can put them, and we can use that to assess air quality at high spatial resolution over a wide area, and to be able to separate out the particulates and the different gases that are contributing to the air quality situation. And we can also use this. The original application was for wildfires, to characterize the environment before, during, and after the fires. So if you have any questions, my email is there. Please feel free to contact me. Thank you.
I guess you probably have a sense of what the opportunities here are, what the scientific advances are that we think we could put into play. This is meant to be an interactive conversation. Happy to answer any questions.
Yes. So to come back to the lithium problem or opportunity, I think we have a global responsibility to do it because we cannot just rely on countries who use slavery and kids, right, to produce it. So we should definitely get involved with it. The economic incentive is great, but I think we need to be extremely proactive at engineering measures to reduce the impact on the environment, right? School to monitor health, but you don't want 5 to 6 years in to realize, hey, the number of problems is 30% heavier. Too bad. We need to do something. We need to do it proactively, doing maybe some experiment at small scale in the lab, right? Across the UCs, we have enough engineer here to kind of come out with an innovative solution. Innovation is a big deal here. And then, apply it, right? And then scale it up as much as we can. Do maybe some, mining at small scale with the APA being involved in generating the standards for healthy mining and processing of that lithium. That would be my recommendation. I hope it will happen. Thank you.
So do a scale experiment before.
Yes, and engineer systems that would prevent the pollution, right? So what can we do to make sure that the lithium is not going to go wacko in the air and kill everybody or make everybody sick, right? So we need to do that.
I think that's an excellent idea. So the conversation we have had so far is by having more eyes, right, the hyperspectrum. So every 2 nanometer, you have the full spectrum, full spatial resolution, and with the resolution is about 2 nanometer spectrum range. Now you can identify the chemical gases species due to the emission from the mining you are doing or from the trucking you're going in and out, and also from the traffic information, right? So I know UCSD and UCI has a very active research program in terms of the work with the California Transportation Department to regulate the traffic. So if we can quantify the air pollution from different metrics, so can we come up with real-time control system, dynamic control system,
Yeah. But
to say, company A, probably you need to stop production, and company B depends on the amount of emission you produce. Right now, overall, in that time, you can continue the work, or truck would not be able to come in. So if we can create a harmony in the society, everyone recognize the need to support the community. Right, so I think it's
being
if we-
able to traceability is super important. And if you can do it precisely, that's fantastic. But that doesn't prevent, the pollution in the first place. So that's what I'm targeting is how can we design systems that will prevent that pollution, not only from the vehicles, we know that carbon dioxide is not good, but from the lithium itself, right? Because it's pretty toxic.
Well, as academics, right, I mean, there's not a whole lot we can do except for give advice because you have a bunch of companies that are out there already doing the large-scale experiment, right? They're really developing already and pushing really hard to get things kind of production ramped up. And what we realized from our last workshop is we don't have the data that we need. They have very few sensors out there bringing in this information. And I think number one is if we can bring in large amounts of data, it'll give us something to analyze to see, who's the big polluters, or maybe it's not a particular entity or company, but maybe it's conditions. Maybe it depends on how hot it is out on the day or the time of year or so on. So I think first we got to get our hands on the data, and then we got to be able to convince people that they might need to change some habits. And I think that's where we can really help as academics is maybe we could do some small scale experiments on our own and say, these activities produce more pollution, and then we could go to the companies and say, look, maybe you can do this a different way. And I think that it's really good feedback. Maybe we could
Yeah.
organize some scale experiments.
Absolutely. So I'm reminded of another effort that we currently have underway. You might have heard me discuss this in other contexts. You know, we got significant funding from the CDC to partner specifically with San Diego Public Health in the context of identifying the next outbreak, so to say. So bring the tools and techniques that academia is good at, but partner with agencies that actually have regulatory authority and can actually create new policies based on evidence that might help improve things. So we by ourselves may not be able to act in that fashion, but we are talking about an opportunity that's been put out by the EPA. EPA is the regulatory entity, right? So they are reaching out to us for exactly this scientific understanding.
Hopefully Donald Trump won't get in power.
You
That's
never
a
know.
different story, right?
Han, did you have a question? Yeah.
I was, I just Googled up actually. So I was a technical question. I'm not from the field. Just a hyper spectral imaging. Is this a camera? Is a fully commercial, right? It's
Yes.
really mature. It just for this purpose, So can this camera be installed on like a microscope or something? It's the same. It should be same. I was just thinking about something else,
Yes.
like different
So,
applications.
The hyperspectrum has two type of spectral modulation technique. Actually, three. Typical in laboratory, they use liquid crystal as a filters, but the resolution is not good.
Right.
And the second one is done in old days by NASA for space exploration to
Right.
find
Right.
waters and other content on Mars and
Yeah.
so on. So they use a so-called acoustical optical tunable filters, and the resolution is about 6 nanometers. And current generation is really leveraging the semiconductor advancements in your camera, right? So now you can do the diffraction patterns to have a good separation of a spectrum down to 2 nanometer, because of the image device has 8 megapixels, so you have a high resolution, and you can outfit to your microscope. And in medical field, this has been one of the active area to use that to study like a hemoglobin, right? So in your blood circulation and others, in medical field, they have been using that technique.
And what's the price typically for this, the third generation, the last one, solid state?
For the third generation, the current generation, it range from 30K to 50K. It's very
Okay,
cheap.
that's okay. Got it.
And our dream is because semiconductor advancement so fast, right? So, and what if we can do a filter directly on those imaging device? One day, everyone's cell phone will have a adapter, plug in, take a picture. Now you have the information on demand at real time in the right locations. That is scalable.
Yeah, that's
Right.
right.
I think one day it will happen,
Right.
maybe 5 years
Thank you.
from now.
Thank you.
Thank you, all directors. I have two questions. One, trying to
Do
understand.
you want to introduce yourself since you'll be
Oh yes, my name is Fuba Rao. I'm the employee of QI. So, what the first question is
He's
about
the director, technical director of our Nano 3.
the Nano 3. So, if you are interested going for a tour today, I will be the one to give the tour. So, so first question, trying to understand, is the question become a problem because of the shrinking of the size of the Salton Sea? If that's the original source of the problem, then I guess this is an easier solution. Just put more seawater into it. So
There's a couple things of the problem. One is they're getting their water cut back because it's getting directed elsewhere. So the region's receiving less water. And it is the shrinking of the sea, but it's coupled with, there's a lot of agriculture in the region and there's a lot of runoff of chemicals into the water. So, there's the three things, I think. And then also it's inland California. Like I, work in Riverside, and on a really hot day, you have all the smog cloud that comes in and floats in from Los Angeles, and it gets funneled between two mountain ranges and gets stuck right in Riverside and kind of moves into the Inland Empire. So you have all these things going against you.
I see. Second question to Director GPD. So I was curious about the reliability of these cameras over the time. So long period of the time, there are spider webs and dust and maybe some birds stuff on the cameras. How reliable are these cameras over the long time? So.
I think that's an excellent question. I think it's if you ask this question to Frank, who currently run the HP RIM, they have deployed traditional camera over the last 30 years, and they have not experienced the issue yet, right? And I was told last winter because of snow, and because too heavy, so one of the station collapsed, right? So, but that's the only one incident we heard, right?
Right. No, this is actually the expertise that the team brings to the problem. HP REN has been running for 25 years. There are 300 cameras on mountaintops, right? This is not a small experiment, and it stays online. And yes, it is true. Sometimes they've had wildfires that have burnt the cameras, and occasionally in the wintertime, if you have a very severe snowfall, the weight of the snow that accumulates on the structures results in the thing falling. But it's surprising, and especially if you factor in the anemic funding that it has received in recent years. It's a miracle, that this technology is robust enough to be able to stand these harsh weather conditions. Alert California has 1,100 cameras all over the state, and it is used in a real-time mode right outside your office, on those display walls that you see. The fire department relies on it.
Thank you.
Same.
Thank you very much. It's very exciting. I'm a very avid outdoor person, so I hike up and down all over.
You should introduce yourself.
Oh, I'm sorry. I'm Elaine Vuong. Actually, alum from the department, from Professor Rao's classes, actually, from many years ago. And I have moved away from San Diego for some years, New Jersey and Colorado, mainly in Hawaii. And these problems we're talking about, I'm mainly very excited and interested in. We have depend so much on imported of everything and outsourcing most of our expertise. So I'm very also concerned about the health issue because it affects me too. And I think that over the years, even right here, we had experts that came and talked about remediation. New Jersey has the most number of Superfund sites, sadly, and Colorado had many mines. And I live fairly close to the School of the Mines in Boulder, Colorado. I live in Boulder, but the School of Mines was in Golden. And then I have family in Australia too. Like mining is happening all over the world. We don't have to reinvent most things. I think just scaling, I think designing every system is important to prototype and scaling because I don't think we want to jump ahead and build things without at least testing them. Because if we have a huge problem, and it's not just above ground, but underground too. There's water, aquifer, salt caverns, and so many things that I've seen over the years that have been sadly contaminated because of human interaction with nature. It's been there, but we mine, we're extracting in a way that was so toxic, and we pump in more chemical. So I think anything we do should be for the better, not the worse. And I'm not an expert at mining, but I've seen enough that I'm sad that we don't just pay for it now, we pay for it many generations to come from all kinds of environmental activities we've done. So I think it's not a new problem. I think the expertise is already there. We should learn from all of them and then hopefully bring in the expert because there are many around the world, not just here, but definitely here we have already quite a few. Governmental as well and NGOs and other groups, and I hope that we'll make the most of it. So I think I'm excited to have something that comes to Southern California, maybe give a chance for the community to redevelop and clean up too, because it's a huge problem and we depend on it for agricultural products too. but I think we should give back and make sure we invest in it. So I'm just throwing my thoughts out there. Thank you.
Picking up on the complexity of the problem in this instance, just to elaborate a little bit on what Shane mentioned in response to Han, your question, Fuwa's question about if the lake is shrinking, why don't we pump more water into it? You know, one reason it's shrinking is because San Diego buys water from Imperial Valley because we have no water here. So they make money by selling us water instead of using it to irrigate their crops, which means there is less runoff and the use of pesticides, combined with that makes the remaining water in the Salton Sea more complex. So there are some aspects of these things it's a complex system. You're not just trying to do lithium mining. You're doing lithium mining in the context of all these other forces that are in play. Should also mention, Elaine, this location is very close to the border with Mexico. It's really one region in many ways from an environmental point of view, and especially if there is going to be lithium extraction and even minimal processing, I don't think it's going to happen in isolation. So I think we have to study this as a binational issue. The people who live there clearly understand that very well, but when it comes to national policies and priorities and so on, it is sometimes surreal. You don't think as a region, you just think as one nation with a boundary which is non-porous, even though that's definitely not true.
Thinking of the whole ecology actually for other species too.
I personally, I think transparency in policy is very critical. And usually when we have the data, information, that can really empower us to take actions. From research point of view, we try to really equalize prosperity and the safety and health of the environment and people, right? So, and if we can make a policy transparent to everyone, and that's what we try to do under the EPA, that can help us to design better system for the future. And we cannot say we want to protect and not grow, right? So otherwise people will move out. And this is what we have seen, a lot of criticism from industry in California, why they are moving out of California, because we have very tight regulation from environmental protection point of view. And they are willing to pollute somewhere else, but it will come back. So how do we really provide the information, make it transparent to everybody, to empower everybody? And this could be a model system, right? California should lead the nation to understand that. We are the blue state, right? So.
Alice?
Speak loud. So is the idea with the monitoring of particulate matter that you would be able to warn a community that this is exceeding safe levels, put on your face masks, or don't play outside? Is that the idea?
That's absolutely one thing you could do, but you could also, monitor with the precision that you have. You could look at different sites. You could look at different mines. Different companies have different mining practices, so you can start to develop data on which ones are more environmentally friendly. And I think there's one other thing is that there's a lot of lawsuits trying to stop some of these projects from coming in. And a lot of companies are, don't want to go in there and get sued by California or some community. And because they're worried that the environment's already screwed up and they're going to get accused of screwing it up. So if we can set a baseline and say, this is what it is, we can give them a peace of mind and saying, hey, look, this is a nonprofit university came in and said, this is what the environment is. And as long as we get feedback and we know that we're not screwing it up anymore, we won't get sued. So I think there's some interest there. I think corporations should invest in this technology as well.
So one of the two large operators there is actually an Australian company, going back to them being experts in automated mining operations. But the other issue, Alison, that I should share with you, and the people who live there know about this, and they brought it up in no uncertain terms at the workshop that Shane organized, is there are very few EPA high-end air quality sensors, like maybe one for the entire valley, maybe. And so there is a concern that they are in the dark, they're kept in the dark. So along comes technology that allows you to deploy hundreds and thousands of small, individually not so reliable sensors, which collectively, using machine learning and other techniques, can be used to get a much better understanding of fine-grained, air quality in different parts of the Imperial Valley. So this is a real opportunity for where academics, I think, have a serious role to play. We can bring a lot more understanding. By the way, if I've been there just very briefly. Nobody in the community is in doubt about the fact that the air quality there is bad. You don't need to tell them that. They know this already. And they know what they need to do is to have cleaner air. And there are programs already which places HEPA filters and other things in their homes. But what are the long-term prospects? How does one improve the environment? By the way, that was Congressman Ruiz's thing. How do we accomplish both, enhance the quality of life and have greater economic development at the same time? And this is why I think we have an opportunity to step in and play a role.